Hi everybody. Today we will see about monitoring and control system, which is a very interesting topic related with real-time software design. You all might be familiar with a real-time system design now. Real-time system includes both hardware and software. We have to divide the requirements as hardware requirements and software requirements and design separately. And another thing is real-time system will include both functionality as well as timing constraints. So both are needed for a real-time system. Now we see an example of real-time system, that is monitoring and control system, with a simple case study. So it is an important class of real-time system, as I have told now. So what happens here is this monitoring system. Monitoring is nothing but monitoring whatever is happening over there. So it continuously check sensors and take actions depending on the sensor values. So monitoring system examine the sensors and report their results regularly. Control system takes sensor values and control hardware actuators. That is what. So the case study which we have taken for today's discussion is burglar alarm system. So what is a burglar alarm? So it is designed to detect intrusion of or an unauthorized entry. So we might have gone out locking our house. If somebody who is not authorized enters the house or breaks the lock or cuts the grill in the window, something like that, so it detects that and makes an alarm. So it is mainly used in residential, commercial, industrial and military for protection against burglary. That is nothing but theft. So you can also see a comic which is always provided when we discuss about burglar alarm. Somebody stole my burglar alarm system itself. So this might also happen. We should be cautious on it. So coming to the point. So here the burglar alarm system. Here in this burglar alarm system, we have to monitor the sensors on doors and windows to detect the presence of intruders in a building. Okay. So when a sensor indicates a break-in, the system switches on the lights around the area and calls the police automatically. That is what we have designed our system. So system should include provision for operation without a mains power supply. So in most of the cases, what happens when a thief enters, he will first cut the power supply to the house. So when power goes off, your burglar alarm is not working. Then what is the use of having that burglar alarm system? So your burglar alarm system should also work when the power goes off, and also it senses the breaking in the system. That is by means of monitoring the sensors in doors and windows. And when somebody enters, it automatically switches on the lights around the intruded area, and also it calls for the police automatically by making a siren or sending message to them. So in this case, what are the sensors you need? So you need movement sensor detectors. So if anybody is moving inside the locked house, it has to detect. It has to detect when somebody breaks open a window, somebody breaks open a door. So you need these three types of sensors. So I have shown some sensors, movement sensor and door sensor pictures I have shown here. So how many you need? So approximately we have designed, for our design, let us take 50 window sensors and 30 door sensors and 200 movement detectors. Okay. So it is not just for a room a single movement detector is enough. No, you have to keep it in all 6 corners, all 8 corners, so that it becomes very effective. And also we need additionally a voltage drop sensor, because we want our system to work even if power goes off. So what are the actions to be taken? So first we have to identify what are the sensors needed and what are the actions to be performed. Okay, when an intruder is detected, police are called automatically. That is first action. Lights are switched on in rooms with active sensors. Sensors are making signals, their lights will be made on, and an audible alarm is switched on. So, and also similarly, when power goes off, a backup power is given to the system so that it doesn't goes off even if power is shut. These are the sensors and actions needed. So coming to our real-time system design process, first we have to identify the stimuli and the responses. Then we have to define the timing constraints associated with the stimuli and response, and we have to allocate system functions and to concurrent process, and next we have to design algorithm, design a scheduling system, and integrate with real-time executors or real-time modes. So now we'll see what are the stimuli and the response. So when power goes off, power failure is detected by a aperiodical stimuli, because when power goes off, the stimuli gets activated. So it will have a circuit monitor. When power goes off, it switches to the backup power within 50 milliseconds. That is what we need. For an intruder alarm, we have the input stimuli are similar generated by the system sensors. Here it is periodic stimuli. Okay. So response to the call of police, switch on lights, and the audible alarm. Their power failure, the sensor is aperiodic, so only when power goes off, it makes the action response. Similarly, but in case of intruder alarm, which is by means of the stimuli from the system sensors, there it is a periodical stimuli. So we'll see the stimuli response and the timing constraints. So when power fail interrupt stimuli, it must be completed within a deadline of 50 milliseconds. Door alarm should be polled twice per second. So for each second, 2 times sensor will sense and send the signal. Similarly for window alarm and movement detector, twice per second is the timing requirements. What are the timing for responses? Let us see. To make an audible alarm, should be switched on within half second of an alarm being raised. So audible alarm, so it should be switched on. Your alarm should be switched on within half second of detecting a person. Light switch should be switched on within half second of an alarm being raised. Similarly, communication, the call to the police should be started within 2 seconds of the alarm. And voice synthesized message will be created, and it is made within 4 seconds of an alarm to the owner of the house and the nearby police. So here you could see the concurrent process. So movement detector, we have already told it is 400 Hertz, because twice we are doing, there are 200 movement detectors we have already designed, and we have each sensor will detect twice and report to us, so we have 400 Hertz, frequency will be 400. In case of door sensors, we have 30 door sensors per second too, so 60. Similarly, window sensors are 50 per second. You have 2 times it reports, so 100. So that's why it has mentioned. So summing up all these things, you get 560 Hertz as a alarm sensor signals to the building monitor process. So this building monitor and room numbers are given. If anything happens, automatically the lighting control process lights the alarm, the lights in the respective room. Audible alarm will be made. Power and all these things happens when you have when your alarm is turned on. Okay, so when there is an intruder is sensed by the sensor, the alarm system process creates an alarm signal which makes the lighting on, which creates an audible alarm, which synthesizes a message and communicates to the persons whom to be alerted. And the other area of sensor is power failure. If power failure happens, the power switch process switches to the alternate power source. So these are the codings for this particular building monitor process 1 and 2. Next is control systems. Here a burglar alarm system is primarily a monitoring system. It doesn't make a control. Does the burglar alarm system catches the thief? No. So it collects data from the sensors, but no real-time actuated control is there. It is just making an alarm to the nearby person or the police. So control systems are similar, but in response to the sensor values, system sends control signals to the actuators, and the actuator makes and controls that particular situation. So let us see a simple example for this monitoring and control system. Monitoring at temperature and switches the heater on and off. Say for a room, if you have a temperature control system, a thermostat process will be there. If you have set a particular temperature, the sensor will sense. If the temperature value goes below or less, accordingly, what happens? The heater control process makes the heater on. Can you understand? So we are controlling the temperature of the room in a particular maintaining in a particular temperature. So here monitoring is there as well as controlling is there. In the previous stage it is purely a monitoring system, it doesn't do the actual controlling process. So coming to the last part of assessment, can you match this burglar alarm system, door sensor, periodic symbol, temperature control, movement sensor with the right hand side things which I have mentioned? Burglar alarm system is a monitoring system. Door sensor, what happens? It senses twice per second. Am I right? Aperiodic stimuli, power failure is an aperiodic stimuli. Temperature control system is a control system. Okay. Movement sensor, what happens? It is twice per second, or it could be a periodic stimuli. Whatever it is, both are correct. Okay. With this, I am closing for today's session. We'll see with the next topic in the next lecture. Thank you all. Have a good day. Bye bye.